Given the following circuit, determine the complex power dissipated by each element and the power factor at each element. Okay, what am I going to do first? Yeah, I'm going to use KCL and KVL to find unknown values. So first thing, A and B are in parallel. So I know the voltage here is 10 angle 25 degrees. A and B are in parallel. So we know they have the same voltage. And I know the current at this node up here. I know the current here, and I want to find IC. Current out equals current in. So the current going out is IC, and that has to equal -5 with an angle of 20 degrees plus 10 with an angle of 40 degrees. So if I call this node A, KCL at node A, IC is equal to -5 with an angle of 20 degrees plus 10 with an angle of 40 degrees. Very good. 5.57 with an angle of 58 degrees. Okay. Now let's do KCL at this node I'm going to call node B. Now let's do KCL at node B. KCL at node B, current in is IC. IC needs to equal 3 with an angle of -30 degrees plus IE. Current in is IC. Current out is 3 angle -30 degrees and IE. So IE equals IC minus 3 angle -30 degrees, or 5.57 angle of 58 degrees minus 3 with an angle of -30 degrees. 6.23 with an angle of 8. I got 87. It's probably just a little bit of rounding though. 6.23 with an angle of 87 degrees. All right, now we need to find some voltages. The first voltage I'm going to find is the voltage across D. D is in parallel with E, so the voltage across D is 50 with an angle of 45 degrees. The voltage across D is 50 with an angle of 45 degrees. Okay, now we need to find VC. We're going to use KVL in that middle loop in order to find VC. So I'm going to have 10 angle 25 degrees plus VC, because if I go clockwise, both of those are rises, and the voltage across D is a drop. Bless you. So negative VB, negative VC, plus VD equals 0. So that's going to be negative 10 angle 25 degrees minus VC plus 50 angle 45 degrees, and that equals 0. Yes, Miguel. Is that 100? It sure is. Thank you, Miguel. We missed you, Miguel. Negative 100 with an angle of 25 degrees. You're like, I've been right here. What do you mean? All right. Negative 100 with an angle of 25 degrees minus VC plus 50 with an angle of 45 degrees. So VC is equal to, I got 55.7 with an angle of negative 173 degrees. Now that we have all our voltages and currents, we are going to show that our circuit obeys the law of conservation of energy. So we're going to have SA, which equals VA IA conjugate, SB, which is VB IB conjugate, SC, which is VC IC conjugate, SD, which is VD ID conjugate, and SE, which is VE/IE conjugate. And then we're going to add them all together. And show that when we add them together, it sums to 0. We're going to show that our circuit obeys the law of conservation of energy by solving for the complex power for each element. Current into the negative puts a minus sign on my equation. So this becomes negative 100 angle 25 degrees times negative 5 angle 20 degrees. Negative 100 angle 25 degrees times negative 5 angle 20 degrees. The current goes in at the minus sign, just like in DC, when the current goes in and it's drawn to deliver power, it's a negative sign on it. Okay. For SB, the current also goes in at the negative. So this is going to be negative 100 angle 25 degrees times 10 angle 40 degrees. Oops, you know what I forgot to do? I haven't been doing my conjugates. That's negative and that's negative, right? It's negative 5 angle negative 20 degrees and 10 angle negative 40 degrees because it's the conjugate of the current. So I got to flip the sign on the current, on the angle. SC also goes in at a minus sign. So this is going to be negative 55.7 with an angle of negative 173 degrees. And IC current is 5.57 with an angle of negative 58 degrees. Then we're going to do VD here. The current now goes in at the plus. So this is going to be positive. The voltage, 50 with an angle of 45 degrees. And the conjugate of the current is 3 with an angle of positive 30 degrees. And then VEIE is also positive 50 with an angle of 45 degrees. And the conjugate of the current for IE is 6.23 with an angle of negative 87 degrees. It's easier for you to see in rectangular form. So I'm actually going to write the answers in rectangular form instead of polar form so that you can see the power plus J, the average power plus J times the reactive power. So for SA, this ends up being 498 plus J, 43.6 volt amperes. 498 plus J, 43.6 volt amperes. Negative 965.9 plus J, 258.8 volt amperes. 196.3 minus J, 240 volt amperes. 38.8 plus J, 144.9 volt amperes. And for E, 232.7 minus J, 206.9 volt amperes. Right, and so there may be a little bit of rounding, but what you should see is that if you add all that up, you get 0 plus J0, which shows that the circuit obeys the law of conservation of energy. So remember, the imaginary part charges and recharges and delivers and absorbs. So we don't think of the imaginary part as oscillating more than anything else. That's where inductors and capacitors charge and then deliver it back to the circuit. So the thing you really care about is the average power. Positive absorbs, negative delivers. So according to this, the only thing that's delivering power is B because the real part is negative. These are absorbing because the real part is positive. Inductors and capacitors, the sign just tells you whether it was an inductive or is mostly inductive or capacitive load. Because inductors and capacitors can absorb and deliver power. They do both. Right? So the next thing we're going to find is actually the power factor. The power factor is the cosine of theta V minus theta I. The power factor is the cosine of theta V minus theta I. So for example, for A, it would be the cosine of 5 degrees. For A, it would be the cosine of 5 degrees, which is 0.996. It's lagging because the angle was positive. Lagging because the angle was positive. 25 minus 40, cosine of negative 15 degrees. What is that? What's the cosine of negative 15 degrees? Oh, so my answer is right. Okay. Cosine of negative 15 degrees, 0.966. That one is leading. It's a negative angle. Oh, I know what it is. No, it's not. It's lagging. It's because there was this minus sign out front. So this flips. This is cosine of 165. It won't change the answer, though. It's lagging. It's 165 degrees. Does everyone see why? It's because this minus sign out here flips the sign. So it actually did it for this one too. So that one should have been leading. Yeah, that's wrong on here though. Because it would have been, so the negative and the negative becomes a positive, right? So that means 25 minus 20 is 5 degrees. So that's why that's lagging. Down here, you have 25 minus 40, which is negative 15 degrees, but there's a minus sign out front. So it flips that angle by 180 degrees. That's why that one's lagging. Miguel? Okay, so the same thing's going to happen here. I'm going to have negative 173 minus 58, but then there's a minus sign out front, right? So that one is going to be cosine of negative 51 degrees. So that's going to be 0.633 leading. The good news is the last two are positive in the front, so you don't have to do that. D and E don't have a minus sign in the front, so we don't have to do that. So I'll just have 45 plus 30 is the cosine of 75 degrees. The cosine of 75 degrees is 0.259. It's positive, so that's lagging.
45 minus, oh, no, I'll do it again.
Get you every time, Alfred, get you every time.
Hopefully not.
Okay, sorry, it doesn't get you every time. 45 minus 8.67. And then find the cosine of that one. I'm sorry, 45 minus 87. Lord, can't read my handwriting. 45 minus 87 is negative 42. So the cosine of negative 42 degrees. Cosine of negative 42 degrees is 0.747. I'm loud. All right, it's leading. Other questions?